8.5. Dividing radical expression. So dividing with a radical number is more difficult than dividing by an integers. So the idea is we want to get a radical free in the denominator so that all the divisor become an integers. So the process of clearing this radical either in the denominator or in the denominator mainly for this case is called rationalizing the denominator. So you have to remember this terminology, rationalizing denominator. Meanings we want to clear the radical in the denominator. So here's the strategy. Always first simplify the denominator, and after you simplify the denominator, the radical terms that we need to work with it will be a much smaller number and less variable. After you simplify the denominator, then you have to pay attention on the divisor is one term only or two terms, because depending on the case we're gonna use a different approach. If it is one term only, then we want to use this property right here, because once we can make the index and the exponent of the radicand the same, we can say that they cancel it out and I only left with a, which is no more radicals. If it is two terms, we're going to multiply by the conjugate factor of the denominator, because from the previous session's last example, we noticed that if two conjugate factors multiply together, the result has no radical symbol. So let's take a look at on the first type of problem. This is a division. So now what we're going to do is we're going to try to simplify the denominator first. So this basically gives me, using the quotient property, square root of 3 over square root of 32. Now simplifying this part, the denominator, 32 has a perfect square number, which is 16 times 2. 16 is a perfect square number, so when I simplify, it will be square root of 3 over square root of 16 is 4, and I left with square root of 2. Now I need to get rid of the radical symbol part. Square root, the index is 2, so all I have to do is multiply by another square root of 2. So square root of 3 over 4 times square root of 2. So this is how I'm looking at it, how I'm determining. Square root 2 has exponent 1, right? The square root, the index is 2, so I need to make sure this exponent become 2. So I need to multiply by another square root of 2 to the 1 power. Okay. So only if I multiply it that way, then this will become, take a look at this, equal to square root of 3 times square root of 2 will be square root of 6 all over 4 times square root of 2 times square root of 2 will become square root of 2 to the second power, which is square root and square, they cancel it out. That gives me my answer, which is square root of 6 over 4 times 2. So which give me square root of 6 over 8. I'm writing step by step, so may seem a little bit longer, but you need to practice it this way to make it very clear for yourself. Okay? So let's take a look at on the next example. 5 over cube root of 9y. And we know that cube root of 9y I cannot simplify any further. So what I'm gonna do is, for the numerical part, okay, always the trick is always write it in prime factorization. Alright, so let's put a note right here for rewrite. Okay, rewrite for this one, right? For one term, rewrite. After you simplify it, rewrite number in prime prime factor form. Now why? Take a look at this. So cube root of, if I rewrite 9 into prime factorized form, that means that will be what? 3 to the second power times y. That will makes it clearly for us what is another factor that I need to multiply by so that the end, so that, okay, what happened? Okay, I don't know what happened. Okay, got it. So that this index and the exponent of the radicand will be the same. So for this case, by writing this number in prime factorized form, I can clearly see that now I have a cube root for the number 3. I have 3 to the second power. So in order to make the index and the exponent become the same, I need to multiply by another 3 to the first power. Similarly for y, to make the index and the exponent of y the same, then I need to multiply by y to the second power. So like we are basically filling the blank, what is missing. So now, to make it equivalent, I have to multiply to the top also, 3y squared. So finally, when I multiply it together, this will become 5 times cube root of 3y squared all over cube root of 3 to the second power times 3 to the first power become 3 to the third power times with y to the first power times y to the second power become y to the third power, which give us our final answer, 5 cube root of 3y squared over cube root and then third power, they cancel out, so it'll become 3y in the denominator, and that's my final answer. Let's take a look at on the next example. Pause it and then try this problem. See, you can basically get the idea that I introduced it to you on the previous example. Okay. So here, this time we are trying to rationalize the denominator with the fourth root. So when I prime factorize 36, that is basically what? 4 times 9, so it'll be what? 2 squared times 3 squared. So I'm rewriting this 36 in terms of prime factorizations format, which is 2 to the second power times 3 to the second power times x to the third power. That helps us to see clearly what is the missing factor that I need to multiply by so that I will get the index and the exponent of each base have the same factor. So 2 to the second times 3 to the second times x to the third power. Now, we're going to multiply by, to rationalize it, fourth root of, I have 2 to the second power already. I need to make 2 to the fourth power, so the missing will be what? I need to multiply by another 2 to the second. I have 3 to the second power already, so I need to multiply by another 3 to the second power to make it 3 to the fourth power. I have x to the third power already, so in order to make it x to the fourth power, I need to multiply by another x to the 1 power. So this is the number that we found out to multiply. So simplifying this, that will become, when I multiply it out, this will become 4 times fourth root of, my bad, fourth root of 2 squared is 4, 3 squared is 9 times x. And in the denominator, this will become fourth root of 2 to the fourth power, because 2 squared times 2 squared is 2 to the fourth power, times 3 squared times 3 squared is 3 to the fourth power, times with x to the third time x, that will give me x to the fourth power. Now, simplifying this, which allow us to get fourth root of 36x. Fourth root of 2 to the fourth power, full root and full power, they cancel out, so it will become 2 times 3 times x. And finally, this is also a factor, remember, so I can reduce this 2 and then 4, in which my final answer become 2 fourth root of 36x in the numerator all over 3x in the denominator. So when the divisor is only one terms, we are basically using this property to clear the radical. So that's the main idea that you need to remember. Okay. Now, let's take a look at on rationalizing with when the denominator is two terms. So when the denominator is two terms, you have to remember to multiply with conjugate factor. So the conjugate factor of square root of x plus square root of 2 is the same identical term, but opposite operation. So that means square root of x minus square root of 2. That's what I'm multiplying by. So when I multiply this, your denominator is difference of 2 square format. So it'll be square root of x squared minus square root of 2 squared using the shortcut. In the numerator, you can distribute it, or you can leave it in factor formats for now. So square root of 5 times square root of x minus square root of 2. So when we simplify this, that will become square root of 5 times square root of x minus square root of 2 over square and square root cancels out, so it will be x minus 2. And this will be my final answer. So when you are dividing by two terms in a divisor, right, then you multiply by the conjugate factor. So similarly for the next problem, if I have p to the square root of p plus square root of 2 divided by square root of p minus square root of 2. So to rationalize the denominator, I'm going to multiply by the conjugate factor, which is square root of p plus square root of 2. Square root of p plus square root of 2. Multiplying this, that's basically in the denominator, same as before, we use the shortcut formula, which is difference of 2 squared. So that will be square root of p minus square root of 2 squared. In the numerator, notice that we are multiplying square root of p plus 2 times square root of p plus 2. So we can use the shortcut formula first square plus 2 times first time last plus last square. Or you may FOIL it and then simplify. So once again, I encourage you to remember the shortcut formula because a lot of time that is a lot faster. So as you can see that, right? So now this will become square root of p squared, so that will become p in the numerator, plus 2 times square root of p times square root of 2. Since they have the same index, I can multiply the radicand together, which will become square root of 2p, plus square root of 2 squared. Square and square root, they cancel it out, so it will become 2. In the denominator will be p minus 2. That will be my final answer. So if it is two term, you need to remember we need to multiply by conjugate factors to the denominator. And this concludes the section.